Good afternoon again. We're looking at number 10 from the triangle proof practice. These problems, I selected them because they didn't have a huge level of just difficulty. They give you a decent amount of the statements and reasons provided, but it's just kind of having to go through and be systematic and understanding the process and how you want to prove some of these proofs where I wanted to provide these as examples. So we'll go over number 10 right now because this document, these problems are actually, I think, due tomorrow. So look at number 10. So they give you the diagram. Given um, point N is the midpoint of line PO. We have LM is congruent to OP, the segments. You can tell by the one hash mark on either one of those triangles. And LN is congruent to PN, those two segments there, and those signified by the two hash marks. So right away for the statement, they give us one here that says that segment LM is congruent to segment OP, and that's provided to us up top where it says given. So we just have given for this one. Number two, or step two here, we're saying that segment LN, if I can write that correctly, let me just go back on that one. LN, no, go back. There you go. LN is congruent to segment PN, and that was given to us up at the top, so that also is given. Number three, N is the midpoint of segment MO. Like at the top, that was given to us also. Let me make this a little bit neater. It's N, not M. Oh, dang it. I just said what it was and wrote the wrong thing. Okay, N is the endpoint of MO. So now with that being the case, right, if N is the midpoint of MO, it also means that N is a point where it's bisecting. N is bisecting MO. And we talked about the word bisect, that bisect, it means to split in half. So if you're bisecting something, you're going to split it in half, which means that whatever's being split in half, both of those segments and both of those parts on opposite side are going to be congruent. So N is splitting MO in half. So that means that segment MN is going to be congruent to segment NO. And so that's one way we can prove it there. Let me see. I think could we also? No, we're gonna keep it there. Sometimes we could do with this to solve it. We're gonna keep it there to keep it a little more simple and plain. So if n's the midpoint of MO, that's given. But now number 4, or step 4, if we have that N is the midpoint of MO, now we're going to, in the next part, talk about the segments we now have because of that line being bisected by point N. So now, if that being the case, well, we have the 3 hash marks on, we're going to say that now segment MN is congruent to segment NO. And that's due to midpoint theorem. It'll have theorem there, but we'll write it, midpoint theorem. Now, we just talked about earlier here that if you have a segment being bisected, both of those segments that are now that have been created are now going to be congruent. And then now 5. Now, based on what we have above, right, we have the 1 hash mark on LM is congruent to OP. So those two segments are congruent on both triangles. We have segment LN is congruent to segment NP. Those two are congruent on both triangles. And then we have the one that we just created by the midpoint. Segment MN is congruent to segment NO. So we can tell we have all 3 sides of both triangles proven. So now we can say that triangle LMN is congruent to triangle PON. And then now this is due to SSS theorem, side, side, side. And our proof is now completely done. QED, completed, nothing else to prove. We are finished. So if any part of this was a little confusing, if it was, this was recorded, go back, replay it, go back. If my handwriting is sloppy, I do state several of things that I'm going to write, or I state what I'm going to write several different times. So if it is sloppy, it's like, what does that say? Go back, and I would have already stated what it was that I was going to write. So this is number 10 off of triangle proof practice. Yeah, done.